All right, welcome to the very first video through chapter 4, which is movement through a membrane. And we're going to look at this in two parts. So the first part will actually take 3 videos to get through, and that would be passive transport. And then the next set would be active transport, which will come later on. We're going to look at passive transport, and we're going to look at how this works with the cell. So first thing it says is that it's movement across the cell membrane without any added energy. So we don't have to expend any ATP. Remember, that's the energy of the cell, adenosine triphosphate. So we don't have to add any energy to move stuff across. And it is the movement of areas from high concentration to low concentration. So where there's more molecules to areas that are less. And eventually, this motion from high to low will end up with everything being equal. And we say that that substance then is in equilibrium, that there's the same amount of molecules on both sides. And that's why I have the picture of a balance there to show that they are the same on both sides. Okay, we're continuing with passive transport. And we're going to a vocab term which says which is concentration gradient. And concentration gradient is the difference between concentrations within the substances. So the concentration difference between high concentration to low concentration. And another thing that makes this passive transport is that passive transport is movement down the concentration gradient. In other words, we're going from high concentration to low concentration. And so the picture that we have right here, you can kind of see that it is a sloped, kind of a negative slope line. So the C would be concentration. I have more molecules right here. I have less on this side. And so that's what it means is we're going down the concentration gradient. All right, now we get into a vocab term, which is diffusion. Diffusion is why when you walk into your house, you smell chocolate chip cookies. You're not by the oven, but you can smell it. Or some of you on Monday walked into school and could smell bacon from the cheerleaders making bacon for the football players. Or your friend sprays perfume in the hallway, and all of a sudden the hallway smells of that perfume. It's movement of high concentration to low concentration. And this is called by random motion of the particles. So molecules are constantly in motion. And as they're constantly in motion, eventually areas that are highly concentrated will eventually move out to areas that are less concentrated. And I got 2 pictures. The one on the bottom left shows high concentration, and we're going to move to areas of low concentration until we hit that equilibrium, that balance. Same thing on the one, high concentration, the blue, low concentration, the white. And so diffusion would be passive transport. It's going down the concentration gradient or going from high concentration to low concentration. Does not cost any ATP. Okay, Brownian motion, and this is a nice vocab term. It basically says that molecules are constantly at a random state of motion. So even a solid will have its molecules move, not very fast, not as fast as what would be in a gas, but molecules are constantly in motion. And you can kind of see this picture, like here's a particle, you can see that there's this constant motion going on with this. You can see the different arrows. Molecules are constantly in motion. You can see where they were, where they're going. So molecules are always in motion. All right, so we got into our first video, and this is how diffusion works. So I'm getting that loaded for you. Okay, kind of like that Brownian motion that we talked about, always in constant random motion. Okay, and remember as he's showing this, this is high concentration of sugar. The water is low concentration. So what he's saying is that how fast these move, temperature, warmer temperatures will get stuff to move faster. We know that in dissolving stuff. Size of molecules, large versus small molecules. The last one is the steepness of the concentration gradient. So if there's a big difference from high concentration to low concentration, it's going to move faster. And if it isn't as great, it's going to move slower. All right, so we got that nice little video. Next thing I'm going to ask you to do is you're going to draw a series of images that explain your understanding of diffusion. You may use an example you've seen in class or use your book as a reference. You can look at the internet to kind of describe what's going on. You can do a Google search, but you need to show the number of molecules on each side of the cell membrane and how it changes over time. So my suggestion is maybe start with like 7 molecules on one side and none on the other, and kind of show how over time we reach this equilibrium, high concentration to low concentration. And you have kind of a series of several drawings showing that they would be same on both sides. I suppose seven's not a good one. It'd be easier to do an equal number to show, so maybe 8 on both sides. All right, and that is our first video. This is on passive transport, and this is video number 1. Remember, there's 3 sections of passive transport before we get into the other half, which is active transport.